Good day, everybody. Today, our lesson is going to be elements, molecules, compounds, and I'm going to explain to you the definitions of those three terms. Okay, so the first thing we're going to talk about is elements, right? We know that in the periodic table, there are 118 known elements in the universe, all right? And elements are pure substances, meaning that they are made of only one kind of atom. So, if you look at oxygen, if I have a tank of oxygen gas, it will only be made from oxygen atoms, right? If I have a gold bar, it will only be made of gold atoms. Right, so it is chemically bonded, which means it cannot be broken down through physical means such as boiling, sorting, filtering. So if I take the element of oxygen, right? Oxygen in a tank, and I try to break down that oxygen, I won't be able to break it down through normal means, such as maybe with my hands, right? Sorting with my hands, or filtering it, or maybe boiling it. I have to go through a chemical procedure to break down an element because it is a pure substance. Okay. Usually, when you break down an element, further, when you break down an atom, then it usually causes an explosion. Okay, the next thing we're going to talk about is molecules. All right, molecules are a very important concept because when you take more than one atom, right, when you take one atom and you bond it to another atom, you get a molecule. All right, obviously, not only just bonding it to another atom, you can bond it to as many atoms as you want, but then you're going to get something known as a molecule. So if you look at hydrogen and oxygen, we know that hydrogen and oxygen are both diatomic molecules. What does it mean to be diatomic? Well, it means that the element has two atoms bonded together in nature. So remember I taught you guys how to remember the diatomic elements. You say have no fear of iSCOBIA. So have stands for hydrogen, right? And no stands for nitrogen. Okay, so in this box here, it says there's a mixture of hydrogen and oxygen molecules, and as you can see, if the red ones are oxygen, because oxygen is bigger, right? We know on the periodic table, oxygen has a bigger atomic number. Oxygen has 8 protons, and hydrogen only has 1 proton. So therefore, oxygen will be bigger. Oxygen is bonded together as 2 atoms in nature, and so is hydrogen. Hydrogen also has 2 atoms bonded together in nature, and that's why we call them diatomic molecules. So just to recap, a molecule is when you take 2 or more atoms and we bond them together, right? Okay. The molecules of a compound always consist of 2 or more different kinds of atoms, like the molecules of water in the following diagram. So notice that I'm using the word compound here, right? The molecules of a compound. So if I take, for example, water, water is made out of hydrogen and oxygen atoms, right? So these small guys in the top are going to be hydrogen, because we know hydrogen has a smaller atomic number, so they look smaller, and oxygen is going to be in the middle, right? So if you take water and you look at it through a microscope, all right, through an electron microscope, you'll be able to see that the smallest part of water is going to be this little Mickey Mouse shape, which is basically made of 2 hydrogens, and 1 oxygen atom. And when you take 2 hydrogen and you bond it to an oxygen atom, you get 1 molecule of water, right? And a compound is basically a substance, right, that is made out of molecules. So a compound is water, table salt, carbon dioxide that we breathe out. There's so many different kinds of compounds in the world. Everything is made out of compounds. Everywhere you look, everything is made out of compounds, right? So if you take many water molecules and you put them in the same place, you're going to form a compound. All right, let's look at compounds. So a compound is a material, example, or substance, example water, which is made of trillions of molecules that form a compound. A compound is a pure substance, meaning that it is chemically bonded. You can't just break down a compound through physical means. Like you can't break water into hydrogen and oxygen. You can't separate those atoms by just, boiling water or maybe like filtering it or something. You need to go through like a chemical process to break down water. For example, in sodium chloride or table salt, there is one chlorine atom for every sodium atom. For every sodium atom, let's ignore this last part there. So if we look at sodium chloride or table salt, right guys, the salt you eat every day is made out of chlorine, which is the bigger compound, and sodium, which is the smaller one, smaller atom. All right. So what gives salt its saltiness? The chlorine inside there. Chlorine is extremely acidic on its own. So if you just we use chlorine in our pools, we use chlorine in our detergents to clean our floors and our toilets. It's a very strong substance. If your skin comes into contact with pure liquid chlorine, then you can burn. Okay, but when we take chlorine and we bond it to sodium, the symbol for sodium is Na, then we get something that's actually edible, salt. So if we look at this is one molecule of sodium, and over here, just imagine that this is a little grain of salt, right? This block over here. So if in this grain of salt, there are trillions of sodium and chlorine molecules. Okay. All right, so the formula NaCl represents one formula unit of NaCl. So what this basically means is that NaCl is the chemical formula which tells us that this block is basically table salt, right? So the common name is table salt and the chemical formula is NaCl. All right, so it says here at the bottom, the sodium chloride compound consisting of sodium, which is the purple atoms, and chloride or chlorine, which is the green atoms, is in a fixed ratio. And we're going to talk about that now. Okay, so the molecules in atoms are, the atoms in molecules are combined in a fixed ratio. In water, for example, one oxygen atom is combined with two hydrogen atoms. All water molecules are exactly the same in this respect, all right? So you're never going to find a water molecule that has two oxygen atoms and one hydrogen atom. Then you're going to get a totally different substance. It may be even a poisonous substance that you're making, right? But if you bond exactly two hydrogen atoms and one oxygen atom, you're going to get water. So if you do not put it in this ratio, right, then you're not going to get water. For example, you're baking cake and you use the recipe tells you that if you want a cake made for 2 people, right, you need 1 egg and 5 cups of flour, for example, right? If you don't put that ratio, right, then you're going to form maybe something that doesn't even look like a cake, number one. And secondly, it's not going to be proportionate. It's not going to taste like a cake either. It's going to be something different. But if you use the correct amounts of each ingredient, you're going to create a perfect substance. All water molecules consist of one oxygen atom and 2 hydrogen atoms, and this gives water its specific properties. Any other combination of hydrogen and oxygen would not be water. For example, Hydrogen peroxide consists of the same elements as water. It contains hydrogen and oxygen, but the ratio is different. There are 2 oxygen atoms that are combined with 2 hydrogen atoms. So if we look at the bottom over here, we have hydrogen peroxide. As you can see, we have 2 oxygen atoms and 2 hydrogen atoms. So we still have the components of water, but can you see how just one more atom makes all the difference? And if we recap, we know that this is called a molecule because you have 2 different types of atoms bonding together, right? Okay, just a few other examples here. Let's look at how we form certain substances. So we have, over here we have hydrogen, then we have oxygen, and we have carbon. C stands for carbon, right? If we wanted to make water, we just have to take 2 hydrogen atoms and oxygen, we bond those, and we form a molecule of water. Okay, remember, a molecule is the smallest part of a compound, right? A compound is like the substance, the material, the actual water, right? If we break down the water into its smallest part, we come to its molecule. If we want to break this molecule down, we break it down into atoms. Okay, then if we want to make carbon dioxide, we take 1 carbon atom and we take 2 oxygen atoms and we bond them together to form carbon dioxide. What if we had to take all 3 substances, all 3 elements, and put them in a molecule? And then we're going to be getting battery acid, right? Battery acid exists in our batteries, and it is extremely strong, right? If it comes into contact with your eyes or your face or your skin, it burns you. It can lead to blindness as well. So we see that we have carbon in the middle, we have 3 oxygen atoms and 2 hydrogen atoms, and this gives me 1 molecule of battery acid. Okay, so guys, I think another very important aspect of the elements that we need to talk about is diatomic molecules, right? So normal atoms on the periodic table, they exist as 1 atom at a time, right? If we look at carbon or sulfur or helium, all of those atoms exist as just 1 atom on its own. But we have another type of atom. We know that they are called diatomic molecules, right? Why are they called molecules? Because there are 2 atoms that are bonded together, right? And we know from the definition of a molecule, it is when 2 or more atoms are bonded together. So if we look here, and this is just a revision of what we spoke about before. How to memorize the diatomic molecules is with the sentence, have no fear of ice cold beer. And can you see how I've written each of these atoms, guys, each of these elements here? I've written hydrogen as H, right? And at the bottom I've put a 2, and I've put a 2 to show me that there are 2 atoms of hydrogen in that molecule. Same for nitrogen, same for fluorine, oxygen, chlorine, and bromine. Okay, and you're never going to forget it if you remember the sentence here. Oh, and I actually forgot iodine. Iodine is just an I with a 2 at the bottom. Okay, moving on. We come to the next thing, which is chemical bonds. All right, so what holds together water molecules? What holds hydrogen and oxygen and keeps them from splitting apart? We call those chemical bonds. All right, so let's read. What holds the clusters of atoms that we call molecules together? When atoms combine to form molecules, they do so because they experience an attractive force between them. The forces that hold atoms together are called chemical bonds. We cannot break these chemical bonds through physical means, like breaking them with our hands or boiling them, etc., etc. Next, we need to be reminded where compounds come from. Compounds form during chemical reactions. In all chemical reactions, the atoms in molecules rearrange themselves to form new molecules. This is how compounds form. The atoms in one set of compounds separate as bonds break between them, and they get rearranged into new groups as new bonds form. So guys, let me put all of that, those words into actual explanation. So we look at this chemical reaction here, right? We're starting with, by the way, this is carbon dioxide that we get in the end. We start on the left side of the arrow, right? We start with carbon. We have one carbon atom, right, plus 2 oxygen atoms. And why does oxygen exist as 2? Because oxygen is a diatomic molecule, right? When we take these two and we add them together, the bonds that tie oxygen together, we sort of breaking it up. So we break the bonds which bond oxygen together, all right? And everything here is going to rearrange itself to form carbon dioxide, to form an entirely new compound, all right? So we see that in this, in the product over here, product is basically what is formed at the end of your reaction. We have carbon, which was initially on the side here, that goes in the middle. And then we have these 2 oxygen atoms which split from one another and went on either side of the carbon atom. Okay, so to further explain, a chemical reaction occurs, right, when the bonds break in one set of compounds, they separate, right, and they get rearranged to form new bonds, right? So to say it again, when bonds break on one side of the arrow, right, to form new bonds on the other side of the arrow. In the example above, the elements to the left of the arrow are called reactants. They are arranged to form a new compound. This is called the product, and it is shown to the right of the arrow. So everything you see on the right side of the arrow is called a compound, or it's called a product, right? And everything you see on the left-hand side, you can have product compounds here, but we usually have an atom or molecule, and those are called reactants because they need to react with one another, right, in order to form a product. Can you describe what happened to the atoms and bonds in this reaction? Discuss which bond broke, which ones formed, and how the atoms are rearranged. So we did speak about this. We said that oxygen, the bond that's holding oxygen together, breaks, and then oxygen bonds with carbon to form an entirely new compound called carbon dioxide. Okay, and the last thing we're going to talk about today is chemical formulas, right? The final aspect of compounds that we learned in grade 8 is that each compound can be represented by a unique chemical formula. A compound has a chemical formula. A chemical formula of a compound is the same for all the molecules of that compound. When we read the formula, the subscript tells us how many atoms of a particular element is in one molecule of that compound. So guys, just to break it down for you, we know that a molecule is the smallest part of a compound, right? So a compound is a substance like water or carbon dioxide or the oxygen that we breathe in. And if we look at H2O, H2O is a molecule of water, right? And we see the 2 next to the H. That means that's basically, those numbers are called the subscript, right? The subscript 2 tells us there are 2 hydrogen atoms in one molecule of water, right? Remember, this entire thing is a molecule. There are only 2 hydrogen atoms in one molecule of water. But what's next to the oxygen? There's no number next to the oxygen, so O has no subscript. That means that there's just one oxygen atom in a molecule of water. When we write H2O, we actually mean H2O1. According to convention, we do not use 1 as a subscript in formula, and so the first formula is the correct one, which means that there are 2 hydrogens in every 1 oxygen. This is also a ratio and can be written as 2:1. We will practice writing formula in the next activity. Okay, so guys, for homework, what I want you guys to do for me is you are going to complete this table here. It says in the following table, the name of some pure substances are given on the left-hand side of the column. The middle column tells us what 1 molecule of each compound is made of. So let's try to complete this table together, right? So we have water. What is water made out of? We know it's made out of 2 hydrogen atoms and 1 oxygen atom. How do you write the chemical formula? It's written as H2O. Okay, and I'm going to make one more column here for the ratio, right? Oops. Ratio of atoms in the molecule. Right, so for water, for example, we know that it's 2:1. All right, that's my ratio. Let's look at carbon dioxide. There's 1 carbon atom and 2 oxygen atoms. So that tells us how we need to write it. Remember, if there's 1 carbon atom, it's just C, and 2 oxygen atoms. So we know that we need to put an O. I'm just going to use my equation thing. So it's C, it's O, and it says there are 2 oxygen atoms. So we know that there needs to be a subscript of 2 next to oxygen. Okay, I hope this is making sense. And if I want to make a ratio of the atoms in that molecule, it's just 1. It's just 1 to 2 over there, right? I want you guys to do the same for ammonia and methane. So there's 1 nitrogen atom and 3 hydrogen atoms. You guys will know how to complete it. Look to the answers before to get hints. Okay, so for today, that is what I want you guys to do for me. And then we just have a few more questions here. Question number 1. What holds the atoms together in a compound? We know those are chemical bonds. The following diagram shows how carbon and oxygen react to form carbon dioxide. What are the reactants and the products in this reaction? So tell me, what's the name of the reactants? Remember, reactants are on the left-hand side of the arrow and products are on the right-hand side. So guys, with regard to reaction in products, remember that a product is something that's made at the end. Like if you're baking a cake, your reactants would be egg and sugar and flour. What would be your product? Well, the cake that you get in the end, right? So after you took all of these reactants and you put them together and they bonded with one another, they created a product at the end. Why is oxygen represented as 2 circles together? Well, we know that because oxygen is diatomic, therefore it will be 2 atoms bonded together. Lastly, magnesium oxide has the formula of MgO. What does this ratio tell us about the atoms in the compound? Well, what I want to know is how many atoms of each element there is in this compound. So there's 1 magnesium and there's 1 oxygen. So write it down in a sentence for me. So in your sentence, you must say, if this compound formula tells me that there is 1 magnesium atom and 1 oxygen atom in the compound of